Okay, now the question is, when we do this question, you also should know where is one means by generated ATP. The ADP generated ATP has two ways to do. Number one is called substrate level phosphorylation. Number two is called oxidative level phosphorylation. Can you tell me where is the substrate level phosphorylation happens? Of course, right here. Is that right? This is substrate level phosphorylation. Okay, then where is oxidative phosphorylation? Of course, right here, is that right? Phosphorylation. Now, what's the difference between them? Oxidative phosphorylation related to electron transport chain, and substrate level phosphorylation, no ETC involved. This is the first thing you need to know. So 8-ATP net generated from glycolysis. Remember, this is aerobic respiration. Okay, if I ask you, is only an individual glycolysis, how many ATP generated? There are going to be only 2 ATPs. Because we don't consider right here. Okay? So this is the first part. Okay, second part. I have to move the camera a little bit. The second part. I'll now go to the side. Okay. Second part, we're going to calculate, of course, there is a transition step. Don't forget. Pyruvate goes to acyl CoA. This happened one thing. Yes, NAD reduced to NADH2. How many ATPs? That was 3 ATPs. Okay, so we added that. Okay, this guy gonna go seven. You see a circle right here. Okay, we don't want to write all the chemicals. Somewhere here. Okay, you know citric acid. Is that right? Somewhere here and here. Alpha keto glutarate. Susi nail CoA. Think of what? Susi nail. How many? What happened? Then go all the way up. Don't forget GT. Goes here. There's one FAD becomes FAD H2. Somewhere here is NAD reduced to NADH2. Okay, how many? 3 ATPs, 3 ATPs, 2 ATPs, 3 ATPs, and 1 GTP that's equals ATP. So how many? It's also 3 ATPs. How many 3 ATPs?
3.
There's one there. 1, 2, 3, 4. Encoding transition step. And the 2 ATPs coming from FADH. And the 1 ATP substrate level phosphorylation. So how many here? 15 ATPs. Remember we have 2 cycles. So 30 ATPs. And add up together here, 8 ATP. So equals 38. Okay, if you want to do 2.5, you change everything become 2.5. Then here become 1.5. You do. It's about 32 ATPs. Is this clear? That's a procedure you should know. We do it again and again, many times. Okay. So that's a question. Now, we have a question for you. I think it's very good. Let's look at this question. TCA cycle, I wrote it that way. It won't happen again in the exam because I'm going to write 2 chemicals. That's too easy, right? You just copy and paste. So, but here is a question which lets you practice. Are there oxidative phosphorylation happens? If so, label them. Where is oxidative phosphorylation? Anything right here? Anything right here? Right here? Right on the top? And here, these are oxidative phosphorylation. How do you know? Because they relate to the electron transportation. Okay? Is there a substrate level phosphorylation? Yes. Where it is? Right here. That's substrate level phosphorylation. The GTP at this moment is back up like an ATP. Okay? So that's question. Label the places, which is called the transition step. SOED. That's the transition step. Okay? It's not difficult. Pyruvate become acetyl-CoA is transition step. Define metabolic precursor. Do you know what is a metabolic precursor? I haven't mentioned this one too much this time around. Alpha-ketoglutarate is a metabolic precursor. If I still remember, malate right here on the top. Oxaloacetate, that's a metabolic precursor. And you go here, succinyl CoA is also a metabolic precursor. So this, if you want to see this, the answer of this question, you need to go back to see your slides. I think the slide somewhere right here. You need to go back to see your slides right here. And the slides right here, we talk about what is metabolic precursor. This guy, alpha-ketoglutarate, acetyl-CoA, and the oxaloacetate, these couple of them are metabolic precursors. I didn't mention this semester. I just tell you, these are also pyruvates. These are metabolic precursors. Now, I have other questions for you. Name one chemical in this cycle related to the biosynthesis of protein and fatty acids. Which one is for protein and fatty acids? The alpha-ketoglutarate. I didn't mention this semester. That's fine. I mean, you don't have to worry. And the pyruvates, those two. Okay, so, question number 4, you can skip that, but I just let you know that's something we call a metabolic question. Okay, so that's a question we want to talk. Okay, one more question I want to talk, then we end up today. This is something important right here. Back to fermentation. Okay, so we want to talk about this guy. These are the big questions. Tuesday, we can talk about all those small ones. Then we move on to the final exam. Pyruvic acids become lactic acid. NADH become NAD plus. First question, name this type of biochemistry reaction used by microorganisms. Is this easy? Total fermentation is right. If you don't know this, then you have a huge problem. Okay? But then you should know this is a hormone. Okay? Hormone fermentation because it's generating lactic acid. What is reduced products? What is oxidized products? What is reducing agent and oxidizing agent? One more time. Reduced products. Oxidized product. Reducing agent. Oxidizing agent. Some people left it black. Then I say, you're so dummy. Don't guess. If you don't know what you should do, write one chemical. You at least get one, is that right? You need to be smart sometimes. Don't guess. You guess you're wrong. 25% you get correct. Right now everything the same if you forget it. I don't know why somebody just left it empty. Why I ask you 4 questions? Because you can write the same thing. You at least get, this is only, the year what I did is only 2 points. I think in the final exam is only 2 points. You at least get 0.5, even you don't know. So that's a very nice question, honestly. If I pick, I delete these 2, that might be difficult. I'm serious. You can't guess. Okay? So easy. Reduce the product. What is that? Is that lactic acid? Okay. What is oxidized product? Lose the electron there. NAD plus. Okay, once this is the oxidized product, then this guy is reducing agent. Is that right? Okay, then you left one. You don't have to even think about it. Okay? It is a basic chemical. Usually here in these type of classes, people doesn't mention these too much. This is pure chemical. Okay? So you see lots of the questions. In the testing bank, they're only going to ask these 2. That makes it difficult. They don't talk about this too much because this is pure chemical stuff. But I usually put them all of them. You at least can get one. You can guess. What is the biological function of NAD plus? Is this easy? What is 5 seconds? What is NAD plus? Nicotinic adenine dinucleotide. What is that? What's the function of that guy? Is this easy? Okay. Needs to be recycle. Okay, that's very important. Name one product processed by this reaction. Name the microorganism related to that. It's so many. What is the easiest one? Yogurt. What's the name of the bacteria? Lactic acid bacteria, is it right? Lactobacillus. So this is a very good question to let you study fermentation. So how are we going to study? You're not going to remember the answer. If I change a little bit, you don't know the answer. What you should do when you study this, go back to look at your slides. These slides, we talk about fermentation. This is a conclusion. How many ATP generates through the fermentation? Only 2, coupled with glycolysis. Look at here. It turns back. It will have to be recycled. Application. Is that right? Lactobacillus right here. And then yogurt and cheese. And we have a question asked you, probionic gases, Swiss cheese, you see this carbon dioxide, where they come from? Probiobacteria. It's not difficult, is that right? Okay, so we finish here. We talk about all these big questions, and next Tuesday we're going to go over those small ones, and we have time after we go to the final examination.